All right, here we are with just a bonus video, a real quick one, demonstrating how we can take the code that we wrote in the last video for our new rendering engine, which was based off of the tree command that you guys saw back over in the console command that we had running. What we want to do is show you how we can use that very method with almost no changes at all. So here we are promoting code reuse to, well, create our very own tree command. I think that'd be pretty neat. And it'll definitely demonstrate that we did a good job of recreating what we saw output from the tree command itself.
Right, since this method of drawing was inspired by the original tree command, it'd be nice to see if we could use the renderer to make that actual app reproduced in C#.
Exactly. Now there's some extra things that you guys are going to get out of this as well, seeing how that you can get a directory listing and things like that. So definitely worth watching this video. Again, it's just some bonus material. All right, Logan, let's go and get started.
Okay. Well, I can begin first with a fresh instance of Visual Studio. Inside of that instance, I'll begin a console application, and I'll call it Tree. Now, the heart of this is going to be the same as our advanced renderer from the scene graph. So I'll begin by going to the scene graph in the transform node section where we had written our new show tree, and I'll simply steal the entire show tree method. We'll jump over to our new tree project and put that into place. Now, obviously, if I try to build at this point, there's going to be what looks like a lot of errors, since we're missing, first and foremost, there is no such thing as a transform node, and then later I'm sure we'll need things like the all the characters for the joints.
Exactly, our constants.
As a matter of fact, just to get those out of the way, I could also jump up to the top and pull all of the supporting constants that the renderer uses. So we could put those into place inside of our class as well. So when we get to those, we now have all of our constants for drawing and offsets defined. The next thing we need to address is exactly how the list system is going to work. And in order to do that, I need to show where we're going to get directory information from.
Sure, because at this point, we don't have transform nodes. Directories and folders within directories, I mean,
right,
that's simply not
We're now outside of our
nodes.
own dependency graph engine. So we need to look at what we have available for walking through folders, since that's the idea of the tree app, is to recursively list directories. So in order to get access to directories, I'm going to need the IO namespace. So we'll put in a using to system.io, and doing that will give us access to the directory info class. Directory info can be used to more or less open a directory and then do things with it. Look at things that are inside of it, or even list the directories that it contains. So let's make a directory info called dir inside of our main method. And let me also define a string to contain a path that we want to look at, an actual Windows path. So let's call this string path, and let's turn around and initialize it to some existing path. Now, what would be nice would be to use the actual folder we used when testing the tree utility, and that was the folder in which we have Visual Studio installed. So I'm going to copy that path and use that for our actual path to use. Now, this has backslashes in it, so as opposed to using escaped backslashes, I'll simply use the @ character to use that as literal. So we have a path defined. Now we can turn around and use that to make a new directory info. So we could say that dir is equal to equals new directory info, where we give it our path. So we create a directory info with the given path. Now what we can turn around and use that for, if we jump down, we can say that directory, because at this point we have a directory. The next thing that we need to do is to get a listing of all directories contained within the specified directory. That can be done with dir.getDirectories. Get directories is let me get the tooltip back, it's an array of directory info. That is what I was getting at as what we will need to actually replace our list. Since obviously we don't have transform nodes, we don't even know if we have a list. At this point, we know that this entire thing gets replaced with an array of directory info. And to make this parameter make more sense now, I'll call it directories instead of node list. So directories, and there we go. Now, of course, node list itself is invalid, so I could replace it with directories in each of these cases. I also need to do things like take into account the fact that directories is an array, not a list. So that means when we do things like count, we have to replace that with .length instead of count. And then one final thing is where we had originally done a call to the specific item's children to get a subsequent list. Children no longer exists. Instead, we need to make another call to get directories, since get directories is where we got the list to be, or excuse me, the array to begin with. So if I try to build one more time,
we got to finish the one line.
Yeah, we'll need to finish this line before we build. There's also a few other things to take into account, and that is when we were writing out the name, we had a name and a shape node. In this case, we have no shape node whatsoever, which means I can take this down to a simple append since there's no reason to use formatting anymore, and this becomes simply appending the current directory. That should take care of everything inside of here, and now we can go back outside to the original call, since we have now fixed our show tree to operate on an array of directories. That means what we're actually trying to do here is a call to show tree where we feed in an array of directory info, which is exactly what dir.getDirectories does. And of course we need to specify the starting padding, which will again be a blank string. So now if we build, check it out. We now have this refactored and building in our new method.
Let's make sure we throw a read line in there just to hold ourselves up.
Sure. So that if just in case this does actually work, we could do a console read line so we can view the results.
Okay.
All right, everything's looking good, so we might as well try and run it.
Ooh.
Hey, look at that. Look familiar? So here was the original utility, and here was our version. The only thing different is that up at the very top, the tree utility prints out some information, and then the drive and a dot representing current character. So if we wanted to go all out and completely reproduce the results, we could do this line right here, show what folder we were under.
Okay.
But I mean, other than that, we've got everything up and running, again, with only minor changes. The only thing we really had to figure out was how directories were working versus our original list.
Exactly.
Every other piece of code, you notice that all of the lines still reside. Every single line is the same.
All of the logic remained the same.
Exactly. So, if we want to patch this up and print the character in front of it, what we could do is strip this character out, the D:, out of this, because we could do a string split on backslashes. That would return D as the first element, and we could put that into place and simply show it before we run the show tree. So we could do something like, let's define a string for drive name. So string drive is equal to path.split, where we're splitting on the character backslash, which I'll hit twice because we need to do an escape sequence to get an actual backslash. That will return a string array, but instead of storing it as a string array, I'm simply going to access element 0 to store that in a string. Then we can turn around before we run a show tree into a console write line, where we write out drive. So now if we run and scroll to the top, there we have D. And actually, we could put we could do some formatting again. In this case, WriteLine itself supports formatting, so we could set up our format as argument 0 followed by a dot, and then give drive as our argument 0. And that way, we're able to append a dot without having to use string concatenation.
Very cool.
So now, if we compare it, I'm not going to worry about the drive serial number because I don't want to worry about reverse engineering how the drive's working. But beginning at the D drive line, we can see that they're working pretty much exactly the same.
Yeah, that looks fantastic. Looks just like it.
That also proves that our code is working very well for our tree render, since it can handle an identical output to the original tree utility.
Exactly. Okay, once again, this video was just an extra, real fast bonus video showing you how you could do a little bit of drive stuff. The idea, though, was to demonstrate how we could take and reuse code that we created from one rendering engine that was based on an output that we saw from the tree command, and then basically move all that rendering code over to a new application that completely mimics the tree command. And we've successfully done it. So that is going to finally wrap up this knowledge review section, and it's now time for us to move on to the XNA stuff. Thanks a lot, guys.